Hello, everyone. We're going to talk about fitting a histogram. First, we're going to import our libraries, as I am circling here. Then we are going to generate some data. We're going to use this norm.rvs function to generate a histogram, or a set of data, I should say, that's 500 points across, or we have 500 points, whose standard deviation is 2.5 and whose mean is 10. Okay, so that's what we do first. We're just going to generate some data with this function. In lab, you measured data, and so you wouldn't have to do this step. I'm just doing this because I didn't measure data in the lab. I'm just generating some random data that I know that is going to be Gaussian in shape. Okay, now I'm going to take that data and I'm going to determine what is the mean and the standard deviation of a Gaussian that fits that histogram or fits that data. So the function here is norm.fit, and what this does is take the data that we have generated above and it fits a Gaussian to that data, and it returns the mean and then the standard deviation, which we set equal to mu and STD with this framework. So we're going to run that. We're going to generate the data, fit the Gaussian. Let's see what mu is. This time it's 9.965, our mean, and our standard deviation is 2.601. Every time we run this generate data code, we're going to create a new set of data that is still Gaussian, but a little different from before. So now our mean is 10.2778, and now our standard deviation is 2.46. Okay, we're going to plot this histogram. So we just take the data set generated, arbitrarily use 25 bins, and then set some other factors here for aesthetics. We label the x-axis with score, we label the y-axis with counts, that's just arbitrary, and then we have a title here, for example, histogram. So we plot the histogram of the randomly generated data from above. Now we can plot the histogram and also include the Gaussian fit. So same code here, we're going to plot the histogram, but in the same cell, now we're going to find what we need for the Gaussian fit. We're going to generate 100 points of x values for the Gaussian fit, and then we're going to generate an array of y values that has the same number of cells as the x values. But now we're going to be creating a probability distribution function, a normal probability distribution function. That's what this function norm.pdf does, using x points as our x values, mu as our mean, and STD as our standard deviation from above. We're also going to label things so we can have our proper plot here. So we run that code, and our histogram from above now has a Gaussian lying over top, so we can see the agreement. And we also have our mean and standard deviation shown at the top. I'm going to run this code a few more times so we can see how the histogram and the Gaussian change, as well as the value of mean and standard deviation. Okay, so our histogram looks a little different. Our mean is 10.10. Our standard deviation this time is 2.51. We run it again. Our histogram is a little more skewed randomly on one side, and our Gaussian shifts and adjusts its values as well. 9.79 for the mean, standard deviation of 2.56. Try one more time. Okay, we see we have another histogram again. So I encourage you to take this code. I will post it on the As You Learn page. I encourage you to change things like the data here, the number of data points, the number of bins of your histogram, and see how your Gaussian fit changes with some of those factors. Have fun. Bye.